When a woman becomes pregnant, her body undergoes hormonal changes primarily influenced by two hormones, estrogen and progesterone. These hormonal shifts prepare the breasts for milk production. Shortly before childbirth, another hormone, called prolactin, which is responsible for milk production, increases in the woman's body. After delivery, when the baby begins to suckle, at the breast, it stimulates the nerves in the nipple and areola, sending signals to the brain. Within the breasts, there are small clusters of glandular tissues called alveoli. These alveoli are responsible for producing milk. During pregnancy, under the influence of hormonal changes, these alveoli begin to multiply and enlarge. The mother's breast got around 150,000 alveoli in each breast. This is many times more than the number of alveoli that a non-pregnant woman has. The extra alveoli help ensure the mother can produce enough milk to feed her baby. Inside each alveolus, there are specialized cells called secretory cells or alveolar cells. These cells are the key players in milk production. They produce and secrete milk components such as proteins, fats, lactose, and immune factors. In response to the baby's sucking and nipple stimulation, the hormone oxytocin is released from the pituitary gland in the brain. Oxytocin triggers the letdown reflex, also known as the milk ejection reflex. This reflex causes the muscles around the alveoli to contract, pushing the milk into the milk ducts and out through the nipple. Breast milk production operates on a supply and demand basis. The more frequently and effectively the baby nurses, the more milk is produced. When the baby empties the breast during feeding, it signals to the body to produce more milk to meet the baby's needs. In the initial days after childbirth, the breasts produce a thick yellowish fluid called colostrum. Colostrum is highly concentrate. It's high in protein, vitamins, minerals, and immunoglobulins that help build the baby's immune system. After a few days, colostrum transitions into mature milk, which is thinner and lighter in color but contains a perfect balance of nutrients, including proteins, fats, carbohydrates, vitamins, and minerals, specifically tailored to meet the nutritional needs of a growing baby. It also contains antibodies and other immune factors that help protect the baby from infections and diseases. Breastfeeding has many advantages for the baby's health and development. It helps strengthen the baby's immune system, reducing the risk of respiratory infections, ear infections, allergies, and other illnesses. Breast milk is easily digested, leading to less constipation and diarrhea. It is also associated with a reduced risk of obesity, diabetes, and certain childhood cancers. Breastfeeding provides several benefits for the mother as well. It helps the uterus contract and return to its pre-pregnancy size faster. Breastfeeding can also aid in postpartum weight loss as it burns extra calories. Additionally, breastfeeding has been linked to a lower risk of breast and ovarian cancer. The composition of breast milk can vary from woman to woman and can change throughout the course of breastfeeding. The levels of various components can be influenced by factors such as the mother's diet, health, and environmental factors. Breastfeeding promotes bonding between the mother and the baby. Physical skin-to-skin and eye contact during breastfeeding help strengthen the emotional connection between the two. For the first 6 months of life, the World Health Organization, WHO, recommends exclusive breastfeeding, meaning the baby receives only breast milk and no other foods or liquids, including water. At around 6 months of age, infants begin to eat solid foods in addition to breast milk. Breastfeeding continues alongside the introduction of solids, gradually decreasing in frequency as the baby eats more solid foods. Breast-stopping milk production, or breast weaning, is highly individual, and there is no fixed age at which breastfeeding must end. This can happen gradually and naturally when a mother and baby are ready to stop breastfeeding. The key driver for milk production is demand. When a baby breastfeeds less frequently, the breasts receive fewer signals to produce milk, leading to a gradual decrease in milk supply. Mother's body reabsorbs the milk that is already present in the mammary glands. The breast tissue gradually shrinks. This can result in a reduction in breast size over time. Some women may experience a smooth transition with minimal discomfort, while others may have more noticeable changes in breast size or experience mild discomfort as their bodies adapt. Wearing a supportive bra and cold compresses can help alleviate discomfort during the weaning process.